As we know in science, when we put potent questions and leave with that questions and don't come to the conclusion immediately but observe, then that question itself opens and withers like a flower, and you have a sudden flash and insight into the overall or general nature of the problem. The same things happens with Albert Einstein at the patent office. Much of his work at the patent office related to questions about the transmission of electrical signals and electrical mechanical synchronization of time, two technical problems that come up conspicuously in the thought experiment that eventually led Einstein to his radical conclusion about the nature of light and the fundamental connection between space and time. Einstein thought that the laws of classical mechanics could no longer be reconciled with those of the electromagnetic field, which led him to develop his theory of relativity. He then extended the theory to gravitational fields. Historians speculate that his isolation from the physics community during his employment in the Swiss patent office might have helped him see past the unnecessary trappings people took for granted. Like other physicists of his time, Einstein was pondering several seemingly unrelated puzzles. James Clerk Maxwell equation, revealing the intimate connection between the electrical and magnetic fields, looked very different in different frame of reference, whether an observer is moving or at rest. Moreover, the speed at which electromagnetic fields propagated through space almost precisely matched the speed of light when repeatedly measured by experiments. A speed did not change no matter what. An observer could be running toward the light or rushing from it, and the speed did not vary. The most important quality of Einstein was the freedom from self-protective reservation and barrier with which he responded. When he observed a contradiction between Newton and Maxwell theory on the speed of light, then he begins with a fact like the speed of light is constant. Einstein observed this fact very deeply, and to observe the fact, freedom is necessary. He leaves all his prejudices, even his hypotheses, behind at home. But he pays very close attention to the fact to see what is going on and discover something new, creative and original. And later on, that's become the foundation for the most beautiful theory in physics called general relativity and other discoveries of the modern physics. For books about Albert Einstein's theory and his beautiful manuscript, check out the links in the description box and read them. In the upcoming videos, we will talk about Richard Feynman and his discovery of Feynman diagrams. Thank you.